Hi, my name's Jenny, and today I'll quickly run through my master's project. But first, a little bit about myself. I've been studying at the University of Birmingham for 4 years now. My final project focused on paleoclimates. Now that's finished, I'm just keeping myself busy looking for a job. But in my spare time, I like to do sketches of my foraminifera from the SEM photos. The core I've been working on was collected in the Rockall Trough off the west coast of Ireland as a collaboration between the Rockall Studies Group and the British Geological Survey in 1999. While picking, I occasionally found some fish teeth, which I've included in the top right, but the genera I focused on were Cibicidoides, Lenticulina, and Nuttolioides, as these were the most abundant in the core. Taking photos was my favourite part of the project. I think they can be really pretty, and I'm working towards some kind of art project using them. My original goal was to produce a low-resolution record of stable isotopes through the whole core. As I've highlighted with the red box, I targeted two lithologies. The unconformity between the two spans 3 million years across the Early to Middle Eocene transition, or the Epresian and Lutetian ages. From the oxygen values, I calculated bottom water temperatures, which were then contrasted against the planktic sea surface temperatures. I also wanted trace element analysis of the magnesium to calcium ratio, but due to the COVID-19 pandemic, this was never returned to me. But that's okay, the carbon and oxygen isotope data was still plenty to work with. First, I plotted delta 13 carbon values against geological time, with the global record in the background. Overall, these values increase over time, but exhibit a strong negative offset against the global record. The mean benthic increase is quantified as 0.7 mil, which is explained by the increase in carbonate productivity. The opening of a gateway to the north increased through flow of water, which had the knock-on effect on productivity. A downward pulse of the Greenland-Scotland ridge was responsible for this gateway opening. As for my delta 18 oxygen values, the benthic dataset agreed strongly with Kramer's global record. The benthic values increased through the Eocene, indicating a period of climate cooling. I have quantified this increase as 0.9 mil. Using my oxygen values, I was then able to calculate paleotemperature estimates for this site. Blue arrows show that both benthic and planktic forams exhibit a fall in temperatures through the Eocene. This correlates with climate cooling observed at other sites at this time. My benthic forams show cooling of 4.5 degrees, while planktic forams show a cooling of 6 degrees. The difference between surface and bottom water temperatures decreases through the Eocene, suggesting an improvement of ocean currents and mixing as a result of the opening gateway. Today, the Earth is experiencing global warming and increasing atmospheric carbon dioxide levels. Because of this, many are interested in studying similar periods in Earth's history. The Eocene is one such period, which I have highlighted in this graph to show elevated atmospheric CO2 levels. The Eocene also represents a global shift from a greenhouse to an icehouse climate. By researching how different climatic processes operated during the Eocene, we can make predictions on how the planet will respond to future climate change. I have a couple of bullet points here about where I think this project could go next. I'm just about running out of time, so I'll leave it there. But I hope you found this project fascinating in some way, and do feel free to reach out and ask me any questions about it. Thank you for listening.